Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of SolidCAM's automatic feature recognition on this mold base as we see on our screen. We'll be machining this on a 3-axis CNC milling machine. Now, before we do our feature recognition, we'll first start off with a face mill operation to clear off the excess material that's on the top of the part. If I were to go into the operation itself, if I go into the tool, you'll see I'll be using a 40 millimeter face mill. In my technology area, you can see I'll be working in a hatch mode across the part. Let's take a quick look at the simulation using Solid Verify, and you'll see that the tool will go across the part in a hatch fashion to clear off all of the material that's on top of the part itself. Next, we'll be going into a pocket recognition operation to machine out all of these pockets, these areas as well over here, including these slots over here and these large holes. And we'll be doing this automatically in pocket recognition. Let's open up the operation for a moment. And if we go into our geometry area, you'll see that we've chosen the entire model, filtering out any hole that is smaller than 17 millimeters. And by picking the model, we have every single surface and through pocket automatically chosen. Now, the tool that we'll be using in this particular case will be a 20 millimeter end mill. Now, since these areas over here are open pockets, if we go into our technology, you can see that we have the option of open pockets activated, and we'll be using a profile strategy to work on those pockets. Let's take a quick look at the simulation. You can see that all the pockets are being machined, including those holes over there, and each one of them will be machined to their respective depth. This is automatically recognized by the pocket recognition, and it knows the depth of every single one of those surfaces. In our next set of operations, we'll be doing the drill recognition. In our first drill recognition operation, we'll be doing a spot drill for every single one of the holes that we see on these faces over here. If we were to go into the operation, you can take a look at the geometry, and you'll see that every single one of the holes was chosen automatically, and we did this for every hole that was between 0 and 17 millimeters in diameter. The tool that we'll be using will be a 10 millimeter spot drill with a 90-degree angle. Now, in our levels, we've customized the depth so it actually can go and give a spot drill according to the size of each individual hole. If we go into depth edit, what we've done here is as follows. We've chosen the option of auto chamfer spot drill, and by doing so, every single hole will get automatically the diameter needed for those holes. If we take a look at our simulation, you'll see that every single spot drill was done, and also according to their individual hole size. In our next operations, we've continued using the drill recognition option, but for each individually sized hole. For example, if I were to take the next operation over here, I'll take a look at my geometry, and you can see that we automatically filtered out all the holes, and it's only choosing the holes that are 13.5 millimeters, and it's done so in this group. So only those holes have been chosen for this particular operation. Because of such, the drill that I will be using will be a 13.5 millimeter drill. As for the levels are automatically taken into account according to the depth of each hole. Now, the same was done for every single one of these operations. If I were to take a look at the simulation for all of these operations up until here, you'll note the following. We first have our face mill as shown over here. After this face mill, we'll have the pocket recognition that'll machine out every single pocket according to the depth that it needs to be machined out. Now when it finishes those pockets as shown, it'll also do the slots. After that, it'll start doing all the spot drills and all the holes according to their respective sizes. Now, for our last operation, we've used the option of chamfer recognition. This operation would automatically put a chamfer on all the sharp edges. If I were to go into the operation itself, you'll see that my geometry has chosen every single one of those faces over here, finding every single edge. The tool that I will be using will be a chamfer mill of 10 millimeters with a 90-degree angles. Now, in my levels, all I do is enter the chamfer depth that I want on all of those edges. Now let's go into our technology. In our technology, I've told it I wanted to use a 2 millimeter diameter for the cutting diameter of the tool, as shown over here. I'll be using the 2 millimeter diameter of that tool. Now we have one more option over here, something called safety offset. What the safety offset does is that it keeps the tool away from the wall. So if I have an edge over here that gets up to the wall itself, it won't go to the end of the edge. Instead, it'll stay away from that wall, making sure not to gouge the part. Let's take a look at the simulation, and you'll see that it starts doing the chamfer operation around the part. Now note also what happens when it gets to these areas over here. You'll see the following. It'll machine only up until this area, keeping the safety distance away from that wall. The same thing will be done in these areas as well, keeping the tool away from those walls as shown over here. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for our Professor tab. Take care and have a nice day.